Everyone now able to see my. Hello, students. Do you able to hear my voice?
Yes.
Yes, sir.
Just a minute. I will have to change the setting.
Yes. You.
Now my voice is clear to you. It is clearly audible.
Yes.
Hello,
Sir.
please reply. My voice
Yes,
is
sir.
clearly audible.
Yes, sir.
You.
Hello, please reply. My voice is clearly audible. Hello.
यस सर. हाँ सर, आवाज आ रही है आपकी.
Hello, please reply. My voice is clear, audible to you. Please reply.
Yes, sir.
Hello.
Hello.
Yes, sir.
Now clearly audible my voice. Hello.
हाँ सर, आवाज आ रही है आपकी.
આવી બસ એમ તમે કોને એટલે ગાડી આગળ ચાલે આપણી ત્યાં સુધી મને એમ થાય કે મારો અવાજ નહીં સંભળાતો હોય આપને. ઓકે, હવે સ્ક્રીન દેખાય છે, જોઈ લો જરાક. પ્લીઝ મેક ઇટ કન્ફર્મ. સ્ક્રીન દેખાણી તમારા પેલા પીપીટી. Whether PPT is seen on your mobile screen. કન્ફર્મ હા ના કરજો તો ખબર પડે. યસ યસ બોલવાનું, નહીં તો મને અહીંયા ખબર નહીં પડે. We are in distance place. Okay.
Yes,
Now
sir.
so today we today we start with the chapter of refrigeration cycle, new chapter. In older chapter we may have completing out study about different gas power cycles. We have first study about Carnot cycle, then Otto cycle, then diesel cycle, then dual cycle, made comparison among the various cycles, and at the end we may have make some solutions to the numerical problems for Otto cycle and separately for one lecture in the diesel cycle. Okay. So make confirm whether the student of both the divisions are present here. બંને ડિવિઝનના મિત્રો આવેલા છો ને એમાં લેક્ચરમાં. Please make it confirm. Or either way I will have to see the number of attendees. It is only 20. If there any student of A division, A division ના કેટલા મિત્રો છે? આના કરજો જરા અનમ્યુટ થઈને.
Yes, sir.
Okay, okay. Thank you.
Yes, sir.
Okay, okay. Thank you.
Yes, sir.
So refrigeration can be used to mankind in many ways. We may have to use basically the refrigeration process to conserve or to preserve the perishable items like milk, vegetables, egg, meat, etc. to keep it stored for the longer period. Without refrigeration, if suppose the perishable items to be stored for 2-3 days, with the use of refrigerator that can be stored for the elongated period, you can say 8 to 10 days. So purpose of refrigeration is to keep the temperature of system lower than the surrounding, and so that the same can be used by making the use of refrigeration process. So refrigeration process is nothing but to keep the temperature of system less than its surrounding. If the surrounding temperature is you can say ambient temperature, suppose 20 degree. So your refrigeration temperature will be less than that. You can say 5 to 10 degrees. So that is the storage temperature. Similar way, you can use this refrigeration principles for making use of built environment in air conditioning. But here particularly we may have the study of refrigeration and its cycle in the thermodynamics. So here some picture you have shown which are the scientists who have done the pioneer work in the field of refrigeration. So some of the common name of the scientist is James Harrison. He may have its tenure of working from 1816 to 1893. He has developed one, you can say, cycle working on making the use of ice and some basic refrigeration components to make the working of cycle. So here below some picture is to be shown first refrigerator and third generation of the Harrison family who have produced the ice making machine. So another name you can say will be of Apron. He will have to invented refrigeration in the year 1893. So this is the how the refrigeration comes into picture for to store the perishable items for the elongated period to preserve it for the longer time. So major application of the refrigeration is it make the use of thermodynamic principles which concerns with the transfer of heat from lower temperature region to a higher temperature. Whether the Chauhan sir covered the second law of thermodynamics or not. તમારે સેકન્ડ લો પતી ગયું છે થિયરીની અંદર હાના કરજો જરા
Yes, sir.
થઈ ગયું ને so what is the second law of thermodynamics second law of thermodynamics will have to say you that heat cannot automatically flow from lower temperature region to a region of a high temperature. You might have to provide external work done so that to carry the heat against the natural law of conveying for low temperature to high temperature. કુદરતના નિયમ પ્રમાણે હીટ હંમેશા હાઈ ટેમ્પરેચરથી લો ટેમ્પરેચરમાં મિત્રો ફ્લો થાય છે પણ તમારે જ્યારે એવી જરૂરિયાત ઊભી થાય ટુ ટ્રાન્સફર ધ હીટ ફ્રોમ લો ટેમ્પરેચર ટુ હાઈ ટેમ્પરેચર નેચરના નિયમોની વિરુદ્ધ તો તમારે એક્સટર્નલ વર્ક આપવું પડે. ધીસ ઇઝ ધ સિમ્પલ એક્સપ્લેનેશન ઓફ ધ સેકન્ડ લો ઓફ થર્મોડાયનેમિક્સ. ઓકે, સો દેટ હિયર ઇન ધ refrigeration we may have a refrigeration cycle which works on vapor compression cycle and some chemicals called refrigerant used which will have a low boiling point temperature, and during boiling it will abstracting the heat equivalent to its latent heat of vaporization from the surrounding medium, and so that the surrounding medium can get cooled to a temperature lower than the ambient. So principles of refrigeration. So first one, liquid absorb the heat when changed from liquid to gas. Any liquid required to be boiled, then it must have to absorb the heat equivalent to its latent heat of vaporization, and that is equal to the change of phase from liquid to vapor. And wherever gases can be converted back to liquid by the process of condensation, the same amount of heat to be released by the same is called the latent heat of condensation. So here in the refrigeration, both the process to be occurred in separately the component called evaporator and condenser. In evaporator, vaporization took place at a low temperature. Refrigerant can evaporated at a liquid to vapor, and in condenser the same is condensed back from vapor to liquid. So there are principally two components of refrigeration. You can say vapor compression, that is evaporator, and condenser. So in the most of the time you may have to require a compressor. Compressor will have made increase of temperature of the low pressure vapor into high pressure vapor so that that can possibly condense at ambient temperature and pressure. So to make the difference of pressure prior to flowing through the evaporator, we may have a required one device in the cycle called as a valve, pressure reducing valve. That is also called here a throttle valve, because throttling process can occur here to change of pressure from high to low value. That is aspectable in the evaporator so that the liquid can boil at low temperature. So this is the how it can work. There are four principal basic processes of refrigeration. One is the evaporation. You can say here process 4-1, and then it is the compression 1-2 process. Isentropically heat is added to convert low pressure vapor into high pressure vapor. Then process 2-3, in which constant pressure heat rejection is there in the condenser by the high pressure vapor to convert it into the high pressure liquid, and at the last time we may have the expansion device or a metering device known as a throttle valve, in which the refrigerant is available at a high temperature liquid condition to be expanded to the low pressure liquid refrigerant, so that the same can convert it again into the vapor refrigerant into the evaporator. So this is the cycle of cooling to be used in the refrigeration. In evaporator refrigerants are groups of chemical having the low boiling point, such as ammonia, carbon dioxide, sulfur dioxide, freon, etc. are the different types of refrigerant. You might not have a detailed study of the same. In the chapter of refrigeration, you may have the subjects separately into the 6 mechanical to have a detailed idea about the refrigeration. Then after passing through the evaporator, the same is made to flow to the compressor, then to the condenser and expansion. So there are basically two working sides of the refrigeration cycle. One is the low pressure side and another one is the high pressure side. From the compressor to condenser and from the condenser to expansion valve, refrigeration available in form of high pressure conditions, and from expansion valve up to the compressor, the same is available to a low pressure conditions. So basically the total refrigeration cycle divided into two parts of cycle as per the pressure, low pressure side and high pressure side. So there are four basic components are required to make the working of refrigeration based cooling cycle: evaporator, then to the compressor, condenser and expansion valve. So you must have to remember the order of flow of refrigerant as well as condition from the four different components. Just a minute, I will have to look how many of you may have joined in the lecture. Only 30 students. Where are others? I have already placed the message in the group that I will have to continue with the lecture exactly at 11:45. Till then, most of the students are not found in the lecture. Okay, that's their wish. So first one is the evaporator, where refrigerant boiled to the liquid to vapor low pressure conditions. Then compressor, vapor low pressure vapor refrigerants can be pressurized to high pressure vapor refrigerant. Then it's sent to the condenser. High pressure vapor refrigerant converted to the high pressure liquid. Then expansion valve, where high pressure liquid again made to convert into the low pressure liquid. So similar way, the refrigerant has to work continuously in cycle to make the abstraction of heat at the evaporator and to reject the heat at condenser. So we have to supply external work done for running the compressor by coupling it with the electric motor. તો મિત્રો અહીંયા evaporator એવો component છે જ્યાં heat absorb થશે from surrounding to system, અને condenser એવો part છે જ્યાં heat is to be flow back from system to surrounding. તો અહીંયા એરા બતાવ્યા છે એનાથી આપ જાણી શકો how the heat can flow. So this is the schematic diagram of the working of different components. Red lines will show you the high pressure line. Yellow line will show you the high pressure liquid. Green line will show you the low pressure liquid. And blue line will have to show you low pressure vapor. So here, first of all, refrigerant in the evaporator can get extracted the heat from the surrounding. Then it made to flow through the compressor, where this low pressure vapor can get compressed to a high pressure vapor, and from condenser by rejecting out heat, it converted to high pressure liquid, and by passing through the expansion valve, the same is again converted to the high pressure liquid to low pressure liquid, and the same is again flow to the evaporator. Two places there is a phase change of either the liquid to solid. In evaporator, refrigerant is converted from liquid to solid to absorb the heat, and in condenser again vapor converted back into liquid to given out heat to the surrounding. So the function of condenser is to condense the refrigerant from high pressure and temperature vapor to high pressure and temperature liquid conditions. Only heat rejecting out by the refrigerant is the latent heat of condensation, and so that its temperature remains constant while the same is getting flow through the condenser. Expansion valve will have to reduce the pressure of liquid refrigerant to convert it into low pressure liquid refrigerant. That process is occur by the process of pressure drop at enthalpy drop. The same is called the throttling process. Evaporator refrigerant converts from low pressure liquid to low pressure vapor conditions, and so the heat is abstracted out at a constant temperature. It is only the heat is necessary for to occur the change of phase from liquid to vapor in the evaporator. Compressor, if you send the low pressure and low temperature refrigerant in condenser, may not get condensed at ordinary temperature with the air and water. So that you may require to rise its temperature about its condensation point temperature at which condensing medium, water or air is available. So far, you have to pressurize it to from low pressure to high pressure, and so that you get the low pressure vapor to be converted in compressor in the high pressure vapor. So COP, coefficient of performance, or efficiency of this refrigeration cycle can be obtained by the COP. Its full form is coefficient of performance. It is expressed in the ratio desired output by the required input. Required input here is the amount of work inflow at the compressor, and desired output will be the refrigerating effect in terms of change of refrigerant during its evaporation at the evaporator. So ultimately, it can be given as the ratio of cooling effect to work done. As a thumb rule, COP improves by 2 to 4% for each degree of evaporating temperature rise for condensing temperature to be lowered. Selecting the right refrigerant. There are several types of refrigerant: ammonia, hydrocarbon group, carbon dioxide. So as per the application and need and temperature pressure requirement, were very satisfied with ammonia. So it is mostly used in the industrial, where Freon group refrigerants are mostly used in the household refrigerators. Nowadays, due to environmental sustainability, that can get bind, and there are some green refrigerants. R134 will be common nowadays for the household refrigerator. Mechanical definition of the refrigeration. Mechanical refrigeration is the process of lowering the temperature of the substance less than its surrounding, and capacity of refrigeration is expressed in the term. Term of refrigeration is expressed in design as the rate of from the surrounding equivalent to the heat required to be melting of 1 ton of ice. So that heat liberated is called the 1 TR. So capacity of any refrigeration system can be termed in terms of capital T, capital R, TR, that is ton of refrigeration. It is a equivalent amount of heat to be removed by melting the 1 ton weight of the ice in a closed chamber. So that we have different applications of the refrigeration. First one, it can be used in the removal of heat in the chemical reactions where you may have to require the heat during some exothermic processes. Preservation of the thermoliable substances, it may be used. Liquefaction of the processing gas where low temperature is to be required. Separation of vapor by the distillation process. Refrigeration transit application and freezing drying applications. The same is to be used for lyophilization process. So this is also a basic conceptual cycle to be work for the refrigeration. You have to remember 4 basic components to be used for the process of refrigeration, namely the evaporator, compressor, condenser, and expansion valve. In access to that, to store the liquid refrigerant, certain receiver kinds of components are also to be required, but it is a detailed part, may possibly to be taught to you in you are in the above cycle is to be explained as a compression, 2 to 3 heat rejection in the condenser. You can say process 3-4 is the totaling, and process heat transfer addition in the evaporator is a 4-1. So compressor entropy remains constant. You can say it obeys the first law. W work input is equal to M into delta H. Delta H is the difference of enthalpy prior to and after the flow of refrigerant to the compressor. M is the mass flow of the compressor, and W will be work input given in form of running the compressor by the electricity consumption of the electric motor coupled to the compressor. In condenser, P constant, pressure remains constant. In evaporator, pressure remains constant. In evaporator, we may have lost the heat from surrounding to the system. That is also in terms of M delta H. M is the mass flow. Delta H is the difference of enthalpy of the refrigerant prior and after the inlet and outlet of the evaporator. Similar way, the same is applied to the condenser. In throttle valve, entropy is getting increased so far as you can say enthalpy remains constant before and after the throttling process by passing the high pressure liquid to a low pressure liquid through the expansion valve. And so far as the W work is 0 because of enthalpy is constant. So it is also a enthalpic, isenthalpic process. An amount of heat to be exchanged is also 0. No heat added, no heat rejected. So this is the basic working of refrigeration cycle to be superimposed onto the TS diagram. So cycle point 1 to 2 is a constant temperature process. Similar way 3-4 is a constant pressure temperature process, is a evaporator and condenser. Once heat is to be abstracted by the system, and during a condensation heat is to be rejected by the system. Process 2 to 3 entropy remains constant. 4-1 again entropy to be remains constant theoretically, but practically it gets deviate. So COP can be represented by the numerical representation, refrigeration effect by the work output, and it can be explained mathematically by 1 divided by TH to TL minus 1, where TH is the amount of heat added and L is the amount of heat is to be rejected, or high temperature and you can say low temperature. So this is also the shown the same cycle in the pH diagram. In P is the pressure, H is the enthalpy. So the same way you can compare the diagram to be represent on the TS as well as on the pH diagram. So obvious wherever enthalpy can change during the process 1 to 2, 2, 3, 4, 1, and only 3, 4 enthalpy remains constant during the expansion. So far you can have take the difference of enthalpy to calculate the change of enthalpy at the respective point in the given diagram. So this shows you about the TS diagram. At point 3 saturated liquid can exist, and at point 1 you can say have find a saturated vapor. So practically you can say instead of point 4 dash refrigerant is get expanded for obvious there is a slight change in the enthalpy. It is not a isenthalpic process. So it shows you partially due to a expansion entropy increase by the process of subcooling. So actual process is a 3-4 and theoretical process is a 3-4 dash. This shows you the representation of cycle. Whatever may be the area under curve 4-1 represent the heat absorbed during the evaporation process, and the area under the curve 2-3 will represent the heat rejected to the surrounding by the way of condensation. So COP can be improved up to 4% for each compressor if evaporating temperature is raised or condensing temperature is to be lowered in the cycle. This shows the pH diagram for the working cycle of refrigeration. So some constant pressure lines have been showed here, and you find here what will be the difference among the evaporator pressure and condenser pressure by difference of pressure at the state point P3 and P4. Similar way, you can say theoretically cycle to be carried out at a point 1 to 2s, but practically it is not possible to maintain the constant entropy, not process constant entropic process, but it is occur at a 1 to 2, that is called the idle process. This is pressure enthalpy chart, and how you can see certain blue and green lines to present the region is called the subcooled region. So in this region, process of vapor compression refrigeration cycle, you can say find below the critical point limit, and saturated liquid line is to be shown to the left hand region of the same, and saturated vapor line is to be shown you the right hand side of the diagram. And here you have see here a saturated vapor SV line, and you find the weight regions between this two lines is called a two-phase region. There is partially the liquid, and you can say have partially the vapor to be presented. And below the saturation liquid line, there is a subcooled region to explain you. As the pressure diminishes in the superheat region, lines of constant temperature tend to become the lines of constant enthalpy. So that indicated pressure of vapor beginning to have like an ideal gas, and the enthalpy of its independent pressure. The lines of constant entropy, lines of constant specific volume are shown to be in the part of a superheat region in the PV diagram. So here we might have to take one problem to calculate the numericals. Q by M, that is the mass flow in respect to heat flow, is H1 minus H4, difference of enthalpy at these 2 points. So that will give you the ton of refrigeration to be equivalent to 200 BTU per minute is called the British thermal unit, olden unit to exchange the cooling rate. And it is equivalent to 211 kilojoule per minute is also the work done to be required for a 1 TR capacity for producing the refrigeration. So heat rejected by the refrigerant is a Q dot M is equal to H2 minus S3. In expansion wall, enthalpy before and after will remain same as equalized in the equation, and coefficient of performance beta here shown Q dot Q divided by dot M, W divided by M. So H1 minus H4 divided by H2 minus H4, that is the ratio of cooling effect to work input to the system. Now, here some data is given in problem. You might have to given some pressure and enthalpy. So you might have to find different parameters from the refrigeration chart. So you may have to require a refrigeration table to solve the numericals on refrigeration. તો મિત્રો તમારે આ જે રેફ્રિજરેશન છે ને એના ન્યુમેરિકલ સોલ્વ કરવા માટે you might have to require a refrigeration chart and table, pH chart, etc. So the chart is available separately in bookstall. So you might have to purchase and to kept with you at the time of exam. If the same is not to be provided from college, then your own should be used in the exam. So work of compression can be calculated here by calculating the ratio of M Cp delta T. So M mass is here given 7 by 60 kg, and enthalpy H2 at the end of compression 269 kilojoule, and before it getting to enter compressor 241 kilojoule. So that will give you the power for running the compressor 3.3 kilowatt. So refrigeration capacity can be given out in terms of M dot delta H. M is 7 kg per minute already been given to you in the problem, and H1 is you have in the table 241 kilojoule per kg, and H4 enthalpy is 93 kilojoule per Kelvin. So that will give you the tonnage capacity 4.90 ton of refrigeration. COP, that is H1 minus H4 divided by H2 minus H1. Here H1 is 241 kilojoule per kg, H4 is 93, H2 is 269, and H1 241. So that will give you the COP 5.17 around. So similarly, other problem is there. So try to solve the problem by in your way. Just I will give you 2 minutes. Read the data and try to solve the problem with a note and pen if you have available in a nearby to you. તમારે જાતે સોલ્વ કરવાની કોશિશ કરો. I will give you the 5 minutes. પાંચ મિનિટનો ટાઈમ આપું છું. નોટ પેન લઈ અને સોલ્વ કરવાની કોશિશ કરો. We'll give you just 5 minutes to solve the problem. Here, first read the data. There are some data regarding the use of refrigerant type 134A is given as a working fluid, and that can operate in the cycle between the pressure range of 0.12 to 0.7 megapascal. The mass flow rate of the refrigerant is can be said as 0.05 kg per second, and represent your cycle on the TS diagram to determine rate of heat removal, power input to the compressor, rate of heat rejection to the environment, and COP of the cycle. So now attention here. The same cycle is to be represent lower pressure side. Please mind the arrow to be shown with my hand here in the PPT. 0.12 and whatever may be the maximum pressure 0.7 megapascal. So you have to find out work input to the same. Okay. So that for the pressure 0.12 megapascal is equal to 120 kilopascal. So for saturated vapor line here on the point will give you the enthalpy H1 and S1 from the refrigeration table, and P2 and S2 is 0.7 megapascal. So we will give you enthalpy at 0.2. Similarly, saturated liquid condition at 0.7 megapascal, pressure will give you the enthalpy of saturated liquid as 88 kilojoule per kg. So here H4 is equal to H3. H4 is not given. So by theoretically the process of throttling, it will remain same. So it is equivalent to 88 kilojoule per kg. So now you have to find out heat lost in the evaporator. It is M into delta H, difference of enthalpy H1 and H4 entering and leaving the evaporator. So mass of the flow of refrigerant is given to you here 0.05 kg per second. So 0.05 into 236 minus 88. Difference of enthalpy will give you 7.1 kilowatt of cooling. Now you have to find the work input to the compressor M into delta H. So that will give you the value 0.05 mass flow, 273 minus 236 kilojoule per kg of enthalpy at inlet and outlet of compressor will give you the work input nearby 1.83 kilowatt. So by summing to the both, how much latent heat and work input to the compressor will give you the 7.41 plus 1.83 around 9.23 kilowatt. That is the amount of heat is to be rejected by the condenser. So that COP is QL by W. QL we may have to find here 7.41 divided by W 1.83 will give you approximate CO2 4.06. So available answer 4.06 will be the correct one. Affecting the VCRS, which are the different factors that affect the working cycle. First of all, effect of saturation pressure. What do you mean by saturation pressure? Pressure yet it's either the liquid or vapor conditions. For decrease in the suction pressure. QP is for actual cycle to be not as by ratio of H2 minus H1, but H2 dash minus H1 dash divided by H3 dash minus H1 dash. Though the refrigerative effect in this is as work required is to be increased. So wherever you can say suction pressure is high, so instead of 1 dash, now the evaporation starts at 1. So that your evaporation starts at 2 instead of 2 days. So far it affects the performance of the cycle by reducing the amount of heat transfer at a higher pressure as compared to the lower suction pressure. Delivery pressure. Suppose for the theoretical cycle, it can be said to working as a 4-3 and actual cycle to be said as to working at a state point 3 days. So wherever you can say delivery pressure is high, so it just tend to reduce the suction pressure. Also, performance of the cycle is poor. So you may have to expect a high delivery pressure so as to remove the maximum heat to be possibly from refrigerant to surrounding cooling medium in the condenser. Effect of superheating. So far as superheating will get increasing, refrigerating effect will also increasing. But this will affect the cost increase amount of work to be required from the compressor. Effect of subcooling. Subcooling is the region having the refrigerant temperature below its saturated liquid line. So for subcooling, you can find here refrigerant is expanded to the lower pressure, and so far as its COP or you can say refrigerating effect while at evaporation takes place may be higher. So this is the working of actual and theoretical vapor compression cycle. In theoretical vapor compression cycle, the process occur in 3, 4, 5 way, experimentally or actually. In theoretically, it is just a straight line from 3 to P, but PS will be give you in actual cycle. Similar way from 8 to a straight line in a theoretical cycle, when practically the same can be passed through the states point 6, 7 and 8 in pressure drop while passing through the you can say delivery valve of the compressor. So that is the reversed Carnot cycle. How it can mean for the basics for refrigeration can be taught to you in the next lecture. So today our discussion is up to making use of refrigeration in aiding the principle of thermodynamics, basically the second law of thermodynamics to be there. Just a minute, friends, something happened to my desktop screen. It may get just freezed. Now I stop my screen sharing and be available across you. Okay. Now why only 30 students are there today? Whether both the divisions are there, at least I expect you can say more than 50 students. Whether the student can have the circulation about this lecture today, but I don't know so far why students are not getting in the number to be joined to the team meeting today. Anyone having any problem regarding to which are the discussion have been carried out till the time of starting from to end? કોઈને કઈ મિત્રો પ્રશ્ન છે આજે? ગેસ પાવર સાયકલનો ટોપિક મિત્રો આપણે પતાવી દીધો છે અને આજે નવો ટોપિક રેફ્રિજરેશન સાયકલનો જે છે એ હાથમાં લીધેલો છે. એની ફંડામેન્ટલ્સ આપણે જોયું, એના સાયકલો જોયા, પીએસ ડાયાગ્રામ, ટીએસ ડાયાગ્રામ જોયું, હાઉ ટુ કેલ્ક્યુલેટ પરફોર્મન્સ COP ના મદદથી જોયું, સમ ન્યુમેરિકલ કેલ્ક્યુલેશન્સ હેઝ ઓલ્સો બીન ગોન થ્રુ વાઇલ આન્સરિંગ ધી અનનોન પેરામીટર્સ. તો એ બધું તમારે આવા બીજા પ્રકારના ન્યુમેરિકલ્સની ઘરમાં પ્રેક્ટિસ કરવાની છે એન્ડ ધેટ કેન બી ઓલ્સો given to you in form of tutorial also. બરાબર છે. હવે કોઈ મિત્રને કઈ તકલીફ કઈ પૂછવાનું છે? Anyone having any difficulty? મારો અવાજ સાંભળી રહ્યા છો આપ? હા ના કરજો.
હા સર સંભળાય.
ઓકે ઓકે. કોઈને કઈ ડિફિકલ્ટી છે કઈ આજના લેક્ચરમાં? Now the second lecture of mathematics to be engaged by Professor Rajiv Kumar Singh short a while at 12:45. So you all join there in a combined A and D division together. હવે પછીનો જે લેક્ચર છે ને રાજીવ કુમાર સિંહ લેવાના છે. મિત્રો એમના ટીમ મીટિંગમાં દાખલ થઈ જજો તાત્કાલિક. He might have been continue with 3 minutes. સાહેબને કદાચ ડેસ્કટોપમાં ચાલુ થવામાં કોઈ તકલીફ પડે આ તે થોડી વાર આપણે વેઇટ કરવાનો. મીટમાંથી તાત્કાલિક સાહેબ નથી કરીને બહાર નીકળી જવાનું નહીં, કારણ કે સોફ્ટવેર લોડ થતા કોઈ વખત ઇટ મે ટુ ટેક 5-7 મિનિટ્સ. સો યુ હેવ ટુ વેઇટ ઇન ધી ટીમ. બરાબર છે. કોઈને કઈ પ્રશ્ન છે? હાજરી મેં લઈ લીધી છે. બરાબર છે. તો અહીંયા મીટિંગનો એન્ડ કરીએ કે કોઈને કઈ પૂછવાનું છે? શું કરવાનું છે? આના કરજો જરા. Whether we have to end the meeting. Okay, thank you friends. We have to now meet you next Monday as per appropriate instruction to be received. Thank you.